So today we're going to talk about a little bit of analytical aspects of marketing. I'm going to go through the very basic foundations of a lot of the analysis that we're going to do with any of the cases. Okay, this is not going to be any rocket science. There's not going to be any complicated math here. All we're going to do is going to be division, subtraction, multiplication, and a few percentages. So basic algebra, nothing fancy. I'll discuss a bunch of terms that are important, that are going to show up over and over and over again. And this is basically a very simplistic foundation for a lot of the analysis that we're going to do later. If there are more specific techniques that are required at a later time for a particular case, I will cover them later. But these, many of these will show up in a lot of the cases. Okay. So here we go. First, let's talk about some nomenclature, right? First, different types of cost. I'm sure you know this, and if you don't, well, here we are, right? But you probably saw this in accounting, I hope, and maybe in some other classes. So you have, from a classification that is functionally important, two types of cost, okay? There are others, okay, which are fixed and variable. Okay, and I'm going to make a big distinction between those two. The others I will address in a minute. Okay, variable costs, like the name says, are costs that vary with production. This is the important part. What do they vary with? Production. So if I make more of a product, or if I provide more of a service, those variable costs are going to go up. So a typical variable cost is going to be something like, I don't know, if you're making a stapler, the steel that you need to make the casing or the main chassis of the stapler, okay? That's going to be a variable cost, okay, for obvious reasons, okay? On the other hand, a fixed cost will be something that regardless of how many staplers you make, it doesn't change at all. For example, the lease on a truck that you use to deliver the staplers. Okay, notice that regardless of how many staplers I make, that lease figure is always going to be the same every month. Okay, that's going to be a fixed cost for us. Okay, and then there's going to be two different types of costs within the variable cost. You have direct costs. Those are costs that are directly associated with the production of the product, and indirect costs that might be variable, but they don't necessarily are not necessarily directly tied to the production of the product. Okay, and for all our intents and purposes, the most important distinction is between variable and fixed. So I'm going to stop at that to not add any additional excitement. Okay, now one thing that is important in cases is this idea of a sunk cost. Okay, a sunk cost is a cost that you have already incurred in the past, and it's not relevant at the time that the decision is being made. For example, if you've invested heavily in R&D, research and development, okay, but those efforts have not prospered, like you've invested, let's say, $10 million on developing a new technology for a new phone, but you have not been successful after those $10 million. A sunk cost are those $10 million that you have already spent. So if you're trying to decide whether you should keep investing in that technology, those $10 million are a sunk cost because they are not something that you should be worried about at this point in time. But it's something that oftentimes people bring in the back of their mind, and because of that they make the wrong decision instead of looking at, should I invest an extra $1 million based on what likelihood there is that that $1 million is going to get me to a point where I can actually market that product. Okay, good. So like I said there before, direct variable costs that fluctuate directly with the production. Okay, so for example, materials, right, or labor if they are paid by the hour, for example. Okay, and indirect variable costs will be, like I said, costs that are not directly associated with production, but they tend to go up with production. Okay, for example, sales commissions, right? If you're making more staplers, you're hopefully going to try to sell more staplers, and to do that, you're probably going to have to pay higher sales commissions. So those are not directly associated with the actual production of the product, but they tend to go hand in hand. Okay, good. Like I said, for sunk cost, what are sunk costs? Mostly past either investments or expenditures that are not relevant for the decision that you need to make going forward. Okay, so it's important that you're aware of this idea of the sunk cost fallacy. Okay, which basically is when you're trying to make a decision and you look at the sunk cost as though they are relevant for the future. They are not. Whatever you spent in the past, you spend in the past. What we care about is what you're going to spend in the future. Okay, so what extra expenditures you're going to incur in if you make that decision, those are the ones that should actually fit into the decision-making process, not what you've done already in the past. Okay. Okay, so what we need to talk about next is margins. Okay, what is a margin? Margin is essentially the difference between your selling price and your cost. Okay, now notice when I'm talking about selling price, I'm talking about what that product or service is exchanged at or transacted at. This is not your list price or your MSRP, which might be higher than your sales price. Okay, this is how much it is paid for that product in the marketplace. Right? Good. So margin is going to be obviously an indication of how strong your position is in the industry as a firm, right? If you have a thick margin, if the difference between price and cost is big, that probably indicates that your products are well liked or brands are well liked in the marketplace, and that is going to enable you to have big profits. Right, so margin is an important metric. Okay. Also, other than margin, what we're going to do is we're going to look at, and something that you're going to find quite a bit in cases is this idea of a gross margin. What is a gross margin? Is the difference between your total sales and your total cost of goods sold. Okay. Now, what do I mean by total sales? It's usually going to be your price. I'm going to use the shorthand P instead of saying SP because drawing in the PowerPoint is actually a little bit challenging, and also because most people don't specify SP. But know that unless I say otherwise, what I mean by P is P as the price transacted in the marketplace, not just some sort of list number, multiplied by Q. Q being the total number of units sold in a particular period of time. So this could be for a month, it could be for a week, it could be for a year, whatever is the relevant unit of analysis at the time. Okay, and that's going to be my total sales. Okay, and then I'm going to have the total cost of goods sold. Okay, which is also going to be a function of Q. So you're going to have the total cost is going to have two parts. It's going to have the fixed cost part. Okay, that's supposed to be fixed cost. That's supposed to be an F and a C. Okay, plus your variable cost. Now your variable cost oftentimes depicted as V small c or just small c as a shorthand again, times your total number of units. Okay, so you're going to have cost either that is fixed or that is variable, right? And they are both going to be associated with the production of the goods. Okay, good. So that's going to be your gross margin. Okay, which is oftentimes talked about in maybe less sophisticated version will be profit. Okay, but there are different types of profit, so whenever you see a gross margin, now you know exactly what is the breakdown. Okay, and then sometimes because you're comparing maybe different firms or different products, one thing that might be useful to do is divide by the total number of units so that you can see what the gross margin is per unit. Okay, and all you're doing is you're taking the formula that I just hand wrote and you divide by the number of units, which is big Q. Okay, that's going to give you the gross margin per unit. which will be a reasonable metric to compare when you're comparing, for example, the performance of two different firms or two different products. Okay, that way you can isolate how much it comes from margin and how much it comes from the number of sales. Good. Now, let's do a quick example. The math is very simple, but I want to make sure that you see how the formulas work so that there are no questions, okay? Or if there are questions, there are different ones, okay? So let's just assume that we have a certain sales figure. This will be my total revenue, as in price times quantity, right? So let's say it's 100. Professor, I don't like small numbers like 100. Well, you can add the word million at the end, and then it's 100 million and it looks more important. But arithmetically it's the same, right? And then let's say that the total cost of goods sold are $40 or 40 million, right? Whatever you prefer, but keep it consistent, right? And my gross margin will be just the difference between those two figures. Sometimes you might have to compute those figures, but if you don't have to, they are already given to you. This is all you need to do to compute your gross margin, which in this case is going to be 60, okay? And if you're interested as a percentage, which is something that it's presented oftentimes because that way comparisons are easier, you can divide by the total sales and see what happens. So percentage gross margin out of sales, all I need to do is divide by total sales, which happen to be 100, as you can see in the beginning there. That will give me that my percentage gross margin is $60, 60%, not $60. That's why it's a percentage, right? It has no units, and that enables us to compare things across situations. Okay, good. Now, another term that you're going to see quite a bit in cases is this idea of contribution, okay? Now, what is contribution? Contribution is whatever is left after you remove the variable cost, okay? So contribution, it's going to be your total revenue minus only the total variable cost. That means that the fixed cost is not accounted for like it was before, okay? So this is going to be just your revenue, as in price times Q, right? Remember, revenue, it's always the same thing. It's my price times my quantity sold, right? Again, if I have multiple products, I'll add a little bar to it here to indicate that it's an average, maybe computed appropriately with some weights, okay? But essentially, from a computational perspective, is the same if you already have P and Q. Right, that's my revenue, and then what I'm going to do is I'm going to subtract my variable costs, which are going to be my variable cost per unit, which I'm going to call VC, or just small c for short, and multiply by Q, right? If you are more arithmetically inclined, you can see that another way of expressing this will be P minus VC, which is margin per unit, multiplied by Q, right? I said margin by unit, that's wrong. It's contribution per unit, right? You can see it right here. Okay, good. So that's my contribution. Okay, it's similar to the margin, but now we only subtract the variable aspect. Okay, the variable cost. Okay, good. And now you cannot see this. Let me erase it. Unit contribution will be the same thing. All we do is we divide by Q, right? And because now we're doing it per unit, and that's going to give you your unit price minus your unit variable cost. You could have seen that by dividing by Q the equation that I just erased, okay? And it will give you price minus variable cost, okay, per unit, everything per unit, okay? Now, what is contribution margin? Unit contribution divided over unit selling price, okay? So these are all equations. That way, if you see any of this discussed in a case, you know exactly what it is. Let's do a quick example, okay? So if my price at the transaction level is $5 and my variable cost per unit, VC, is 4, right? My contribution per unit then will be 5 minus 4, right? Will be 5 minus 4, which is going to yield $1 per unit, right? So this is going to be $1 per unit, okay? And my contribution margin is going to be as a percentage, it's going to be that $1 divided over the $5 for the selling price, right? So roughly 20% of every dollar that I get from selling that product is going to go towards making sure that I'm profitable by covering my fixed costs. We'll see that in the break-even analysis that we're going to do in a minute. Okay, good. Now, this is what we're going to do, what I was saying right now, right? We're going to do a quick break-even analysis. This is a very simplistic but useful tool, and this is used a lot in many firms, I would say most firms, right? When you're thinking, for example, about entering a new market, launching a new product, one of the questions that you're always going to have is how risky of an endeavor it is to launch that new product. And a baseline to set that up is to decide how many units of the product do I need to sell for me to be profitable. Okay, so the idea behind a break-even is, you know, I'm going to be selling this product for a certain price. It's going to cost me a certain amount of money in terms of variable cost and fixed cost. Fine. How many units do I need to successfully sell for me to break even? Which break even means achieve a profit of zero, nothing, nada, right? And so that's what we're going to do. Now I'm going to show you how to do this in two ways. First, I'm going to show you graphically. I don't know if it's better or worse. It depends whether you like better diagrams or math, right? And then I'll show you with some math. They are both exactly identical, okay? There is no difference between one and the other, but, you know, depending on what you're more comfortable with, I will do both and you get to choose, okay? So, like I was saying before, what we're trying to do is we're trying to see how many units do we need to sell essentially to achieve zero profits, okay? If we were to sell more products, we will be making a profit. If we sell less products, we will be losing money, okay? That's the idea behind it. And this is, like I said, it's a tool that is used extensively, mostly to determine the degree of risk associated with some of the actions that you're going to undertake. For example, launching a new product, changing your pricing, etc., etc. Okay. And now what we're going to need for this is you're going to need an estimate of your variable cost. To get that, you call accounting and say, hey, folks, tell me what the variable cost associated with this product is going to be. If it's a new product, you might have to make a projection, right? Because you're guessing about what's going to happen in the future. Okay. Then fixed cost, you can also call accounting for that. Okay. And then selling price, right? And that's going to be, at least in principle, your decision, right? So you can actually compute the break-even at different prices and see which one will make more sense. Of course, to decide on the price, you might want to use some more data other than break-even analysis, but this is a tool that we use to gauge risk at this point, not necessarily to make a decision, okay? Good, so let's see it graphically, okay? So how do you determine the break-even graphically? Well, I'm going to create a diagram, and the diagram is going to have the following axis. At the bottom, we have quantity, which, you know, is the number of units produced and hopefully sold, right? And at the top here, we have dollars, because there's going to be multiple things that we're going to diagram here, and they're going to be all in dollars, things like cost or revenue, which they are all in dollars, right? And next, what I'm going to do is I'm going to have a revenue line. Okay, I think it's going to say revenue. I hope it does. Good. Total revenue. Now remember, total revenue is what? Is your price, like I said before, I have the wrong tool. Is your price times your quantity. So if you remember back in the time when you studied lines in math, right? You have quantity here at the bottom, that variable, right? Q. You have P times Q here on the revenue, right? So Q is in both, right? And this function right here, total revenue, is linear on Q, right? We are plotting Q at the bottom, so it's going to be a line. How do I know? Because P is just a number multiplying Q. So P is going to be the slope, if you remember what you studied maybe eons ago, right? Slope, right? So the higher P, the more slope you're going to have, right? So this slope will become bigger for values of P that are larger, right? So here you will have P1, right? Here you will have P2, and here you will have P3, with the understanding that P1 is smaller than P2 and smaller than P3. So P3 will be the largest number. It will give me a revenue line that it's steeper, okay? So as you can see, your revenue is going to vary with quantity. Obviously, the more units you sell, the more money you're going to make. No surprises right there, right? Good. Okay, so we have your revenue line. What else do we have? We have our fixed cost line coming here in the picture. Now, of course, we're going to put them in blue because, I don't know, maybe they should be red, but I already picked the colors, right? So fixed cost, remember fixed cost does not vary with quantity, and because of that, it's going to be flat. It's not going to change. So it doesn't matter how many units you produce, your fixed cost stays the same. How much is it? Well, it's this figure right here. I don't know how much it is. We'll do an example later, right? But it's just a number, right? That doesn't vary, doesn't change. No matter how many units you produce, fixed cost stays the same, at least within the range of values that we're considering, okay? To be reasonable. Okay, good. What else do we have into the equation? Then we have our variable cost. Okay, actually, before I put that line in, I cannot go back. Let me talk to you about variable cost. This line right here, the one that I just plotted, is not really the variable cost, it's the total cost. Good. I thought that I mislabeled it. Okay, the variable cost I'm going to plot for you right now. It will look like this. Like this. My drawing skills are not very good, but that line should be parallel to the line that says their total cost, to this line right here. Okay, why should it be parallel? Because if you remember, your variable cost is this line right here, variable cost. Okay, it's going to be your variable cost per unit, VC, times Q. We already talked about this before, right? That's going to be my variable cost. This is my total variable cost. The production of VC times Q, right? And this line is going to start at 0. Why? Because if your Q is 0, what happens with this equation? This goes away. If Q is 0, if you don't produce anything, and then your variable cost will be 0. So it starts right here, okay? Do you see that? It has to start here at the 0, okay? At the 0 line, okay? Good, good. And then we're going to have our total cost, right? Our total cost is going to be the addition of two parts. It's going to be adding my fixed cost, which we have right here, right? It's this line right here in blue, okay? It's going to be this line, plus my variable cost, which I'm going to not make purple because otherwise you're not going to know what I'm talking about, okay? And how do you add two lines? If you don't remember this, all you do is you do point-wise addition. So you take every point and you just add the two curves, and what you're gonna get is you're gonna get the green line that I'm gonna draw right here, which is your total cost, which is gonna be parallel to my variable cost, but it's gonna start at the fixed cost, because when you produce 0, you still have the fixed cost. Okay, good. Good, 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 good. And where is going to be my profit 0? Okay, my profit should be what color? I don't have any more colors left. I'm gonna do yellow, but it's a little bit light. Okay, my profits are gonna be equal to what? My total revenue minus my total cost. Okay, and at break even, what happens with my profit? My profit is gonna be 0. Now, where are my total revenue equal my total cost in this diagram? Where do these two lines touch? Well, it's right here. At this point that I'm showing right there, my profit are actually 0. And the reason why is because my revenues and my total costs are exactly the same. That's why these two lines touch, because they are on the same point, right? So that's going to be my break-even analysis graphically. Where those two lines touch, that's where I break even. So now you can derive from here what is the quantity at which I break even. Is this number right here, right? And what is the price at which I break even? And it will be this number right here, okay? So this is going to be how you do the graphical representation of a break even. Now, if you don't think this is exactly precise, now we're going to do the same thing without bad writings, bad handwritings from the professor, with just some math. Okay, so let's do it with math. The break even, like I said, right there. Okay, good. Now, how do you do break-even with math? Well, it's exactly the same equations that I just wrote, but now what we're going to do is we're going to solve for those equations, okay? So first, we're going to have my profit equation, which is right here, right? My profit is going to be my total revenue minus my total cost, okay? Now what I'm going to do is I'm going to substitute in here the different components. Remember, total revenue is just my price times my number of units sold, okay? And total cost, remember, it's just my fixed cost plus my variable cost, okay? Remember, variable cost is the small variable cost per unit times the number of units. You have it right here, okay? Variable cost is just the variable cost per unit times the number of units. Fixed cost doesn't vary by units because it's fixed, right? Good. Now all I'm going to do is I'm going to take these two equations right here and I'm going to substitute back in the profits, right? So I'm going to substitute total revenue for P times Q, and I'm going to substitute total cost for FC plus C times Q, which is what these equations tell me that it is, right? And I'm going to notice that at the break-even point, my profit is going to be exactly zero. Okay, that's what constitutes a break-even. So if profits are zero, right, let me draw this to make sure that everybody's on the same page. If pi is equal to zero, that means profits are zero. Maybe that's a little too thick. Let's make it thinner. If this is zero, this is a zero. I don't know if it looks like a zero. If profits are zero, then what's going to happen is my fixed cost plus, sorry, my fixed cost, let me erase that. My total revenue minus my total cost is going to be zero, right? That's the definition of profit, okay? So if these two figures are the same, sorry, they are zero, the subtraction of these two, that means that total revenue needs to be equal to total cost, right? So total revenue, I'm gonna put it over here. Total revenue is gonna be equal to total cost. Why? Because that expression, total revenue minus total cost, is equal to zero, okay? And if total revenue is equal to total cost, you can substitute these two equations that we have here at the beginning. I'm going to erase all this stuff to make sure you don't get lost. Right? And we're going to substitute these two equations, which is the definition of what your total revenue is and what the total cost is. And we're going to substitute them into this expression right here. Okay. And I'm not going to do it with my bad handwriting. I'm just going to point to you that I already did that on the slide, right? So you can see it right here. When you substitute those two, what you're going to get is that expression right there. P times Q is equal to fixed cost plus variable cost per unit times the number of units, right? And now we can solve for either P or Q. You can choose, right? If you solve for P, you get the price at which you break even, which is going to be that expression right there. And if you do it for Q, you're going to get a slightly different expression, which you have right here. Right? That's the expression for break-even, number of units at which you break even. Okay. Notice that it's interesting. And if you want to think about the implications of this and see if it actually makes sense, okay, the quantity at which you break even is going to be what? It's going to be your fixed cost, right, divided by your contribution margin. Okay, that's your price minus your variable cost per unit. Okay, so the way you can interpret contribution is how much are we contributing to the fixed cost that we need to cover before we start making profit. Okay, why do we call it contribution? Because of this, because of the break-even analysis. Now, if you want to do a simplistic example, which I have right here to make sure that you see, okay, if I give you some data, or you get it yourself by doing some research and talking to your accounting department, right? Then you can easily compute the break-even quantity right here, right? So you can just, for example, right? You can, for example, look at how the fixed cost, right, being 300, and you have a variable cost in this case being $590, right? So at a price of 600, what's going to happen is my break-even quantity is going to be 30 units. You can see that by just following the formula. You take the fixed cost 300 and you divide by the contribution margin, which in this case is $10 because it's 600 minus 590, right? And that's going to give you 30 units need to be sold in this particular simple scenario so that you can get a profit of 0. That's what break-even tells you. And now the question is for you to address, can I sell 30 units, or does this look like a difficult endeavor? If selling 30 is challenging because you were thinking you were only going to sell about 10 of them, then this is probably not a good venture. On the other hand, if you were thinking selling 3,000, then it sounds like it's not a very risky proposition for you. That's how break-even essentially works. Now, let's talk about another thing that is going to come a lot in cases, which is market potential. Now, market potential is the idea of how large a market am I dealing with, and how large of a market am I dealing with, or at least what is my best guess. Sometimes we're going to have direct data, like in this simplistic example. Other times you're going to have to make some guesses and then project into the future, okay? But assuming that you have the data, this is how you compute what your market potential is. And market potential is talking about what could the sales be if everything worked perfectly, right? That's why we talk about potential. If we were the only firm in the market, we will get 100% market share, and everybody that is interested in buying the product will indeed actually follow through and buy the product, okay? So let's just take a scenario, and sometimes from the case you will get data like this. So let's say a certain company has two products, A and B, right? And that are competing, both of them in the same market, right? And let's just say that we have projections for sales for each of the products. Here you have the two of them, right? So you have numbers that are maybe a little bit more realistic, 195,000 plus units for product A and 252,000 units sold for product B, right? And if the average selling price, why do I say average? Because maybe sometimes there might be different transaction prices, and what you're doing is you're averaging, because otherwise you need to just look at each of the individual prices and add those, right? That would be painful to do, okay? The average selling prices are $5,348 for product A and $15,000 for product B. Now, what will be the market potential that you expect here? Okay, what are the revenues that you are going to see in the future if this scenario holds? Okay, well, it's simple. Now, all you need to do is multiply your price times your projected sales. These are not actual sales. This is what we think we are going to get. Maybe based on some historical analysis, maybe you are fancying, you're doing some sort of predictive model, maybe artificial intelligence, right? Old school will be something like a regression model. By the way, artificial intelligence, to a large degree, is just fancy regression, right? At least some of it. Good. Let's not get into AI today. Okay. If you're interested, let me know. Be happy to talk to you about it. Okay. So these are your revenues for product A, projected revenues, and these are your projected revenues for product B. So roughly 3.8 billion and 1 billion. Okay, so your total market potential that you see coming in the future, if everything is perfect, is about $4.8 billion. Okay, good. Another market potential example, this is a little bit more elaborate, but you're going to see how it's similar in the sense that you're looking at incorporating all the information that you have about what sales you're going to have in the future. So let's say that there are a number of hospitals in a state. Ohio, could be anything, right? And yes, Ohio doesn't have 10,000 hospitals, I know. This is just a made-up example, Okay, and on average, each hospital, let's say that it has 1,000 individuals with acute hepatitis A, which I know it's a really large number, but you can change acute hepatitis A for COVID and it might actually work out, right? And although 30% of these patients could have benefited from the latest medication available, which happens to be called PGC063, only 3% of them received that medication. And the yearly supply of that particular medication costs $150, right? So that's how much we're selling it for, right? So now what we need to know is what is the market potential for this particular drug in Ohio, right? If, in the future we maintain that 3% penetration level. Okay, penetration level means what percentage of the users, or potential users I should say, are actually using that medicine. Okay, so let's break it down. At 3% prescription level, you have 10,000 hospitals. Each hospital has 1,000 patients, but only 3% of those patients are getting prescribed the medication. So I'm going to multiply the 10,000 hospitals times the 1,000 patients times the 3%. Remember, 3% is 0.03. Okay. And then I'm also going to acknowledge the fact that I'm going to charge $150 for each of those treatments for a whole year, right? So that gives me a market potential of $45 million per year in Ohio. If I don't have any competitors, if everything is perfect, this is why this is market potential. On the other hand, if we can do something to let doctors know about the efficacy of the drug, and we think that that will lead doctors to prescribe it a lot more, maybe going from 3% to 30%, then what will be our market potential under those circumstances? And it doesn't require a lot of math for you to realize that if penetration is 10 times higher, or prescription rate is 10 times higher, your market potential will also increase by 10 times. Okay, at least in this case. It's not always the case. It depends what other things are changing. Okay, good. And then finally, example number 3, let's just, talk about a company that we're going to do a case on, Dell, right? Let's say that, Dell has, let's say, a revenue of 30 million a year. Okay, might be larger, but, we need to start with some simple number, right? And then let's just say that the consumer division for Dell, so Dell sells to consumers and to businesses. So the consumer side is 20% of the total sales. Okay, that means 80% are sold to companies, right? And let's also say that we've, gone through the charts on the case, and we found that Dell has a 10% market share in the consumer market. Okay, and what is the total consumer market then in the United States? What is the market potential in the United States? If we have 10% of the market, okay, and we have sales of 30 million and the consumer division accounts for 20%, then let's break this down. Then what we will do is we will just basically try to find out what are our sales that are coming from the consumer's market. That's simple, right? What we'll do is we'll take our total sales, right, which is 30 million, and we will multiply it by the share that it's accounted for by the consumers, which is 20%, okay? So that's gonna yield a consumer-based revenue of 6 million, that's 30, that's a 3, believe it or not, times 20%, which is 0.23, not 20, right? So when you multiply 30 times 0.2, you're going to get 6 million, right? 30 million times. Good. And then what you're going to do after you know what the sales are for the consumer is you're going to try to guess what is the total market in the United States, what is the total market potential if Dell were to have 100% market share, meaning if there were no other computer manufacturers and Dell was the only company in the marketplace and they could sell all their products to all the customers. Nobody else will buy a Mac, or nobody else will buy a HP, etc., etc. Okay, now to do that, we do know that Dell has 10% of the consumer market. So if we call the total sales for the consumer market in the US X, right, the good old X, and we know that 10% of X, which is the share we have 10% of the market, okay, is 6 million, which is computed that it was 6 million. Then the question is, what is the total market X, right? What is the total sales of computers in the consumer market in the US? And I'm assuming that you know how to solve for X here. You divide both sides of the equation by 10%. Okay, dividing by 10% is equivalent to multiplying by 10. I'm assuming you know that. And if you don't, get a calculator or Excel. And that means that the total market, or X, is going to be equal to 60, right? 60, okay. So the market potential, if Dell could capture all sales in the entire industry, will be about 60. And the last concept that we're going to discuss in this first part of marketing math, it's going to be how to make a sales forecast. Okay, so now that we've talked about the market potential, which is what will be the total market opportunity if everything were perfect, which obviously it's not going to be in reality, what we're going to do is we're going to come up with some sort of way of forecasting what's going to happen in the future in terms of our sales, company sales, or brand sales. Okay, and the way to do that is to start with the big pie, which is the market potential, right? What could be. Right? And then what we're going to do is we're going to thin down what slice of that pie we're going to be able to keep, or we're going to be able to serve as a company. Now to do that, what we're going to do is we're going to use a simple aggregate process of forecasting. There are more intricate ways of doing this, but this is just one technique so that we can actually get some figure based on the kind of information you're going to have in a case. Okay, so you're going to start with the market potential, and we've already discussed a few examples on how you can figure this number by looking at some of the data you're going to have in the cases. Okay, this is the total size that is potential or capable, right? Sometimes you start with just the number of households, for example, in a country or state. Okay, sometimes you can refine it more, like we did in the case of Dell, or in the case of the drug, right? So, and then what you're going to do is we're going to take that total pie that could be, and we're going to basically focus on the parts that we are more likely to get. Well, first, we're going to multiply by the percentage of the market that we're targeting. We're only targeting females. It's unlikely we'll get a lot of males. So because of that, we should take those out of the equation. The way we do that is by multiplying the market potential by these factors that are going to be essentially a percentage or an adjustment. And one is going to be associated with the percentage of the total population that we're targeting. Okay. What else? Then we're going to look at, who can we serve, right? We might not be able to distribute our products everywhere. We might have some areas that we have well covered. We might have some areas that we don't. Like if, for example, we have stores in big cities, but not a lot of stores in more rural areas, maybe our market coverage might not be 100%, maybe 70%, maybe 60%. So obviously, if people need to drive for an hour, they are unlikely to buy our product. Hence, market coverage is another factor that we're going to take into consideration whenever we are trying to forecast our sales. Okay. Another thing that we're going to take into consideration is how many times the customer buys that product that we're selling in a given year. If it's something that gets bought once a year, like a subscription or something like that, then this will not be a factor. But if it's something else, something that you repeatedly buy, like, I don't know, could be something like consumer packaged goods, something like soda, right? You buy soda every week or maybe every month, right? And so in a situation like this, the number of units or number of cans or number of bottles that you buy in a given time frame, let's say a year in this case, it's going to be relevant because obviously my sales forecast is going to be a function of how many of those you buy. And of course, you will go with the average, right? Some people buy 1, some people buy 15. You will just do an average between those, especially if you want to be precise, weighted by the number of people that buy 1 or 15, right? Good. And then finally, we're going to take into consideration the average price of transaction, okay? And by putting all this together, we're going to be able to get a forecast, okay? And you cannot see the whole equation because of my face right there, but essentially what it says is that you take all the figures here, M, T, C, U, and P, and you essentially multiply them, okay? So you multiply the market potential in units, not in dollars, in units, times, the percentage of people that we're targeting, times the percentage of the market that we can cover, times the number of units that each person buys on average, times the price on average for the product, and that will yield us our sales forecast. Here you have an example. Again, let's say the total number of potential buyers is 1 million users or potential users, that we have a target market of 25%. And by the way, this number, I guess, is 25.18% to be precise, right? And then we have a coverage, a market coverage of 75%, maybe because there are certain regions that we don't reach, or maybe because, like I said before, there might be some areas that we are more likely to cover than others, like city versus rural, right? And if the number of units purchased in a year is going to be 20, and the price is 10, what we're going to do is we're going to multiply all these figures, and that's going to give us a total sales figure, okay, by multiplying 1 million times 25% times 75% times 20 times 10. And that way we can at least make a guess about what's going to happen with our sales. And that's it for part 1. Part 2 coming soon.